Hello students, welcome to EPG Pathshala. I am Dr. Ayushi Paliwal from University of Delhi. So students, today we are going to discuss about the module Important Metals, Alloys and Their Applications Part 2 from the paper Functional Materials. The purpose of this module is to make the students familiar with first the classification of cast irons and non-ferrous metals and alloys. Second, different cast irons and non-ferrous metals and alloys, their properties and their uses. So students, let us start with a basic introduction about the module. It has already been discussed that there are four major varieties of cast irons, that is white cast iron, grey cast iron, malleable cast iron and nodular cast iron. So in this module, we will discuss all the four grades of cast irons and their applications. So let us start with white cast iron. Transformation products is lead-burite, that is the mixture of austenite and cementite. If there is no graphite in cast iron, it is called as white cast iron. It is brittle and hard. Fracture surface is brittle and it is white colored. It has very good wear resistance. It can be used as grinding ball liners for cement mixers. Grey cast iron. Brittle cementite network can be dissociated and converted to graphite with the addition of some graphitizing elements like silicon, nickel, copper, or by employing slow cooling, increasing carbon content, etc. This makes the cast iron tough and ductile. Graphite can be of different morphological forms in the matrix of pearlite, ferrite, martensite, etc. Depending on the morphology of graphite, there could be three distinct varieties of cast irons, that is grey, malleable and spheroidized cast irons. Depending on the base microstructure, it can be called as ferritic cast iron, pearlithic cast iron, etc. If the graphite has flaky morphology, it is called as grey cast iron. Generally, flaky graphite forms during cooling after pouring in mold during casting. The properties of grey cast iron are: number one, since making grey cast iron requires much lower temperature than steel, it is much cheaper than steel. Second, it has excellent fluidity and castability. Moreover, shrinkage problem during solidification of casting is almost nil because of volume expansion due to graphite formation from cementite, countering the solidification shrinkage. Number 3, it has excellent machinability due to the presence of graphite, which acts as a lubricant as well as beneficial for chip formation. Number 4, it has excellent damping behavior, again due to the presence of graphite. The applications of grey cast iron are: number 1, due to these properties, grey cast iron finds manifold uses due to high damping behavior and compressive strength. Grey cast irons are used as base of many heavy machines. Number 2, it is used for making automobile castings like engine blocks, engine heads, gearbox, clutch housing, brake drum, etc. Due to the ease of casting, no shrinkage related cavity formation, good wear resistance, etc. Malleable and nodular cast iron. So students, let us first discuss the malleable cast iron. The heat treated white cast iron with a microstructure consisting of distorted and rough near spherical form of graphite is called as malleable iron. This type of cast iron is obtained from low silicon containing white cast iron by heating it to around 900 to 950 degrees Celsius for prolonged duration, followed by slow cooling to 600 degrees Celsius. Cementite decomposes and forms the temper carbon and ferritic or perlithic matrix. Malleable cast irons have tensile strength up to 700 megapascal with an elongation of 10 to 15%. This makes these cast irons suitable for use in automobile crankshafts, chain links, and brackets. Now let us discuss the nodular cast iron. It is also known as nodular or ductile iron, which is produced by adding modifiers like magnesium or cerium in small quantities to dissociate the cementite into the spherical graphite form during solidification process. These kinds of cast irons have high silicon content, and modifier actually allows the growth of graphite in all direction at the same rate. Nodular cast irons have excellent mechanical properties, having tensile strength ranges from 400 to 700 megapascal and elongation around 10 to 18%. It finds applications in agricultural equipments, industrial fan hubs, coke oven doors, crankshafts, gears, etc. Non-ferrous metals and alloys, basically aluminium based. Some of the important non-ferrous metals and alloys will be discussed here. They are all aluminium based, magnesium based, titanium based, nickel based, and copper based. Here we will be discussing the aluminium based alloys. It is one of the most important light alloys extensively used in varied structural applications, especially in airplane and aerospace applications. The main advantage is the weight saving and associated fuel saving due to very high specific strength and lightweight. The mass of the metal required for achieving same stiffness of a structural beam is around 0.59 in case of aluminium as compared to steel where it is 1. Other important properties of aluminium are high corrosion resistance, high electrical conductivity, high thermal conductivity. However, the energy required for the production of aluminium is very high and it is around 75,000 kilowatt hour per ton from ore to commercially pure aluminium. Classification of aluminium alloys. Cast aluminium alloys and wrought aluminium alloys, they are identified by a 4-digit number. Digits in the 100th place indicates the alloying element. Digits after the decimal point indicate the form, means whether it is cast or ingot. Temper designation follows the cast or wrought designation. Now continuing our discussion on the classification of aluminium alloys, the definition for the tempers are: F corresponds to as fabricated, H to strain hardened or cold worked with or without the thermal treatment, H1 strain hardened without the thermal treatment, H2 strain hardened and partially annealed, H3 corresponds to strain hardened and stabilized by low temperature heating. Classification of aluminium alloys. Now the second digit. A second digit denotes the degree of hardness, that is Hx2 equal to 1 by 4 hard, Hx4 is 1 by 2 hard, Hx6 equal to 3 by 4 hard, Hx8 is full hard, and Hx9 corresponds to the extra hard. Now there are some other definitions also, that is O corresponds to full soft annealed, T heat treated to produce stable tempers, T1 cooled from hot working and naturally aged at room temperature, T2 cooled from hot working, cold worked and naturally aged, T3 solution heat treated and cold worked, T4 solution heat treated and naturally aged, T5 cooled from hot working and artificially aged, that is at elevated temperature, T6 corresponds to solution heat treated and artificially aged, T7 is solution heat treated and stabilized, T8 solution heat treated, cold worked and artificially aged, T9 corresponds to solution heat treated, artificially aged and cold worked. T10 corresponds to cooled from hot working, cold worked and artificially aged. W corresponds to solution heat treated only. Now let us discuss about the wrought alloys. 1000 series, they are essentially pure aluminium with a minimum 99% of aluminium content by weight, and they can be work hardened. 2000 series, they are alloyed with copper, and they can be precipitation hardened to strengths comparable to steel. Formerly referred to as duralumin, they were once the common aerospace alloys, but they were susceptible to stress corrosion cracking and were increasingly replaced by 7000 series in new designs. 3000 series are alloyed with manganese and they can be work hardened. 4000 series are alloyed with silicon. They are also known as silumin. 5000 series are alloyed with magnesium. And next, the 6000 series. They are alloyed with magnesium and silicon. They are as easy to machine, they are weldable, and they can be precipitation hardened, but not to high strengths than 2000 and 7000 can reach. 6061 alloy is the one which is most commonly used general purpose aluminium alloy. 7000 series, they are alloyed with zinc and they can be precipitation hardened to the highest strength of any aluminium alloy, and their tensile strength up to 700 megapascal for 7068 alloy. 8000 series, they are alloyed with other elements which are not covered by other series. For example, aluminium lithium alloys. Applications of aluminium based alloys. First application is that the pure aluminium finds applications in electrical industries. Though the electrical conductivity of aluminium is less than copper for equal weight, the conductivity of aluminium is about 200% of copper because of lower density of former compared to copper. Second, in packaging industries, 1XXX series of aluminium are extensively used because of its good corrosion resistance, high thermal conductivity, resistance to ingress of oxygen, moisture, and microorganisms. 3XXX series of alloys have moderate strength and they find application in making beverage cans, cooking utensils, building and roofing sheets. Next application is that the 4XXX aluminium silicon alloys find application in making welding and brazing electrodes. Next is the 5XXX series of alloys are used widely in making tanks for carrying petrol, milk, grams, etc., and also for pressure vessels for cryogenic applications. 2XXX series of alloys are extremely popular because of their high specific strength as a result of precipitation hardening ability. That is 2219 T62 aluminium 6.3 copper can be produced as sheets, plates and forging for structural applications. Next application is that the medium strength, that is 6XXX series aluminium, magnesium, silicon structural alloys have the advantage of good weldability and stress corrosion resistance. Next, since solubility of zinc in aluminium decreases rapidly with decrease in temperature, aluminium zinc magnesium 7XXX alloy has the best age hardening response. The last application, that is cast aluminium alloys like Al 12% silicon, are used for making pistons and cylinder heads in cast iron engine cylinder heads. Magnesium-based alloys. Magnesium alloys have started finding applications in automobile industries due to their very high specific strength, even better than aluminium alloys. Hence, weight reduction and associated fuel saving is possible. However, magnesium alloys have poor corrosion resistance. Hence, research is going on to improve the corrosion resistance of magnesium alloys. AZ81, that is magnesium, 8% aluminium, 1% zinc, is a well-known magnesium alloy used to make tough, leak-tight castings for cars. Titanium-based alloys. Melting temperature of pure titanium is 1670 degrees Celsius and has a density of 4.5 gram per centimeter cube. Applications where large strength to weight ratio is required. Because of its high cost, titanium is used primarily in aerospace applications. Titanium, it has inherent corrosion resistance due to the formation of passive oxide film on its surface. Some of the most widely used titanium alloys are titanium 35V15 chromium and titanium 6Al4V. Nickel-based alloys. Nickel-based alloys are considered to be important strategic metals because of their wide range applications in various fields, like aerospace in the form of superalloy turbine blades, chemical plants, motor blades, making corrosion resistant stainless steels, etc., due to their very high corrosion, oxidation, and heat resistant properties. Nickel and its alloys, they are classified into several groups. Commercially pure nickel. It has good mechanical properties and retains its strength at elevated temperature. It has also excellent resistance to most corrosive environment. It is used in making food processing equipment, electrical and electronic parts, caustic handling equipments, etc. Second type of nickel alloy is nickel copper alloys, that is monads. Nickel and copper form complete solid solution. Most importantly, nickel copper alloy contains 67% nickel and 33% copper, called monal. These alloys have high strength and toughness over a range of temperature, good weldability, and excellent corrosion resistance. Major applications of these alloys are making valves, pumps, marine fixtures and fasteners, chemical processing equipment, oil well drill collars and instruments, etc. Next is nickel chromium alloys. Inconel 600, that is 15.5% of chromium and 8% of iron, is a standard engineering alloy. Other nickel chromium alloys are Inconel 601 and 625 with improved properties. Nickel chromium alloys, they have high corrosion resistance at high temperature, high strength and workability, and high temperature oxidation resistance. Heat exchanger tubing, chemical and food processing equipment, furnace for muffle, etc. They are made from these kind of alloys. Last type of nickel-based alloys are nickel-based superalloys. There are three types of nickel-based superalloys, that is nickel base, nickel iron base, and cobalt base. These alloys contains high chromium with titanium, aluminium to form precipitates. Heat resistant and high strength at high temperature, that is 760 to 980 degrees Celsius, good corrosion resistance and good oxidation resistance are the characteristics of these alloys. Major application fields are aircrafts, space wheels, rocket engines, industrial gas turbines, high temperature applications, nuclear reactors, submarines, steam power plants, petrochemical equipment, etc. Iron is added to replace some of nickel as it has lower cost in case of nickel iron super alloys. Therefore, it is used at lower temperatures. So students, let us summarize what we have learnt in this module. The four major varieties of cast irons, that is white cast iron, grey cast iron, malleable cast iron and nodular cast iron, they were discussed. Non-ferrous metals and alloys, that is aluminium, magnesium, nickel, titanium based alloys were discussed. Their properties, their classification and applications are also discussed in this module. Thank you.